Ladies and gentlemen, boys and girls, children of all ages, we are tutoring today, February 20th, 2020. With me today, I have a wonderful group of students who are going to stay on task, not try to entertain, because that's my job. I'm in front of the camera, not you. You have been working for the last 17 minutes on some problems I gave you.
You right?
All right, so if you're one of my parents from this year watching at home, I emailed these questions home. I'm going to go over some of those. But before I start, we had a special request from Bryce on how to divide by powers of 10. So I'm going to do 3 problems showing division of by powers of 10. Okay? So, Bryce, I have 88 divided by 10. Bryce, what is in the ones place? The 8. Right here is the ones place. So this decimal point goes directly behind it. When I am dividing by a power of 10, so I've got the number 10 here. I move my decimal point 1 place to the left because I'm dividing a positive number. I need to make it smaller. So if I'm dividing it by 10, it's 1/10 as big as it is. So I move the decimal point 1 place to the left. So this would be 8 and 8/10. If I had the problem 2 and 7/10 divided by 100, we already have our decimal point written down. I don't need to figure out where it goes. It's already behind. The 2 is in my ones place, so the decimal point's right behind it. We are multiplying, or we are dividing by 100. Since we're dividing by 100, I need to make my number smaller. Which means I move my decimal point which direction, Kendall? Left. How many times, Kendall? 2 times. So I need to go, if I move it here, that's just once. I got to have something else to move it in front of. So if I move it here, my answer is going to be 27,000. Let's do 15 and 3/10 divided by 10. 15 and 3/10 divided by 10. Andrea, what would my answer be? How many times does the decimal point move to the left?
1.
Okay, so my answer would be
1.53.
good. 1 and 53 hundredths. 1 and 53 hundredths. One more. Let's go 124 and 6/10 divided by 100. 124 and 6/10 divided by 100. Maddie!
Aww.
I have to move my decimal point to the left. How many times, Maddie?
1. Wait, 2 times.
2 times. So in front of the 4, now in front of the 2. So it's going to equal 1 and 246 thousandths. So if you haven't done those problems that are on the sideboard over there, this is 4 of them. I've demonstrated how to do them. So you wanna, if you did them and didn't get a good grade, then you may want to redo them. Oh, all right. So let's look at these word problems that I gave you. And I'm sorry if you're not in my classes and you're watching this at home, you probably don't have this, but I'll read the problem for you. We're going to start with the problem On this side talks about Jonathan. So we'll start with Jonathan. And remember, when we're doing tests and assignments, we got to be able to get the easy problems correct. Jonathan is an easy problem. We have to get all the easy problems correct. We cannot miss easy problems. So Jonathan is finding the mass of different rocks during science class. The first rock he measured had a mass of 0 and 325 thousandths kilograms. So I would probably make a note somewhere. That's the first rock. Because you know how I like having you show work. It increases your likelihood of getting it correct by 98.6%. The second rock had a mass that measured 0 and 348 thousandths kilograms. So the second. And we had 0 and 348 thousandths kilograms. Which of the following representations correctly compares these two masses? Masses. All right, let's look at each answer choice. We have A says can those two numbers be equal?
No.
No, they're not even the same thing. They don't say the same thing, so it can't be A. B is less than.
Oh, it says less. That's less and that's greater now.
Okay, so this one says,
Oh, not
B says 348 thousandths is less than 325 thousandths. Well, when comparing decimals, what I always want, what I expect to see, and I'm sure you did when you showed work on this, is you wrote down the numbers, lining up the decimal points, because you're going to have a test tomorrow, and if I don't see work on it, I'm just going to mark the problem wrong. That'll save me a lot of time. Lots of time.
Oh, yeah.
So now we look. Is there a Daniel? Is there a difference in the ones place? No. Daniel, is there a difference in the tenths place?
No.
Matthew.
No.
Stop,
You.
Daniel, is there a difference in the hundredths place?
Yes.
Yes. This is our first difference. Which one's bigger, 4 or 2, Daniel?
4.
4. So my largest one is 0 and 348 thousandths. So if we look at C, C is written just the opposite of this.
Yeah.
So those are really, B and C say the same thing. B and C are both saying that 325 thousandths is, that doesn't make any sense here. It should be 348. Both B and C are saying that 0 and 325 thousandths are the biggest one. So that doesn't make any sense. Ilaria, what does D say?
0.348 greater than 0.325.
Okay, so those are our 4 answer choices. We have proven our work up here. D is my correct answer because 348 thousandths is greater than 325 thousandths. So we've proven our answer. Our answer should be D on that problem with Jonathan. Jonathan and his rocks.
He rocks. With those rocks. It's so funny.
All right, so let's look. Let's go to the other side. So on the back, the other side where we have Jason. So Jason's playing a card game.
Where?
Oh yeah.
Why did you invite me?
In order to win, okay, why are we talking? In order to win his round, he must correctly match the numerical expression card with the simplified form of the expression. Which pair of cards below shows the correct match? So simplifying, you're just taking the expression and solving it, saying what the answer would be. So let's look at A first. We did a problem like this today in class.
Oh yeah. Oh
Yeah.
yeah. We have
I am now.
Yeah. Don't you remember on the little card?
I don't recall.
What's the card?
Oh yeah.
What's the card? Oh yeah.
Here's an order of operations problem,
Oh.
and we're trying to see if this problem equals 35. Our first part is what? B-Beck, what do I start with? I start with the parentheses. So I'm looking inside the grouping symbol first, and then inside the grouping symbol I have parentheses. So I do that first. And Ilaria, what is 6 times 7?
It is 42.
42. This stays in the brackets, and I haven't used divided by 2. So, B-Beck, what do I do next?
You add 4
2.
to 42.
Good. I add 4 to 42. And Ilaria, what is 42 plus 4?
46.
Thank you.
Should not.
I already knew
And then I do 46 divided by 2. Ilaria, is 46 divided by 2 going to give me 35?
Most likely not.
Most likely not. It's going to give me 23. So A cannot be my correct answer.
Sorry, Anne.
Goodbye.
Let's look at B.
Bye. Goodbye.
Let's look at B just a moment.
Goodbye.
All right, so we're looking at B. B is, we have,
It's good, Mr. McMurray. Please keep it on the camera.
thank you. And we want to see if B equals 23.
No, I'm sorry.
All right, so Cheyenne, what do I start with here?
You add 8 plus
Good, I started my brackets inside my grouping symbol. So then I'm going to treat this like it's its own problem. Inside the grouping symbol, I have the parentheses. So I'm going to do the parentheses first. And Cheyenne, what is 8 plus 15? Oh, okay.
I did add 8 plus 15. I'm lazy.
Good, so now we have 23 times 3 inside my brackets. And then that product divided by 2. So Cheyenne, by 3, sorry. Cheyenne, can you tell me what 23 times 3 is? 69, awesome, nice. 69 divided by 3. 69 divided by 3 is what, Cheyenne? 23. So it appears that B is our answer.
Yep.
I would obviously check and make sure by checking the other two and showing the work. Please, for the love of Pete, when you work out
Who's Pete?
problems with multiple operations, repeats brother, multiple operations, work it like this, showing each step one at a time. So we did that problem today in class. I graded it and I started crying.
We all did.
I really did.
Did I miss it?
Yeah.
All right, so this is another one, but I'm doing this one because I want to make sure you know how to bubble in here. So simplify the following expression. We have 89 plus, does that say 21? Is that 21 divided by?
Yes.
Divided by 10 minus 7. And all right. So, Honeyleth, where are we starting on this? Ten minus 7, because we're inside the brackets. We treat that like it's its own problem. Honeyleth, 10 minus 7 is 3. We're still inside the brackets because we haven't done everything inside the brackets yet. Okay, so now, Honeyleth, what do I do next? 21 divided by 3 is what, Honeyleth? 7. We're done inside our brackets because I've done all the operations inside the brackets. I have 89 plus 7, which is what, Honeyleth? 96. Work it like this, one step at a time. Now, the reason I picked this easy problem to show, Honeyleth, in the number 96, what digit is in the ones place? The 6. The decimal point goes after the 6. Here's my decimal point. I need to put it like this, and then bubble in directly below it. So if you did that problem, make sure you put the 6 directly in front of the decimal point in the ones place. Let's see. Let's look at the Lucy playing card problem. Lucy is playing a card game. She has dealt 7 cards. 2 of her cards show prime numbers, and 5 of her cards show composite numbers. Which of the following group of cards could be Lucy's? So we're going to have to look at each of these. And we have A is 5, 4, 8, 3, 10, 6, 10. Excellent. Excellent. Shania, what am I looking for? What did it say her cards had? How many? 2 prime numbers, and how many composite?
5.
And 5 composite. 1, 2, 3, 4, 5, 6, 7. Excellent. Excellent. Bryce, is 5 prime?
Yes.
Yes. 5 is prime. Bryce, is 4 prime? Bryce, is 8 prime? No, it's an even number. Bryce, is 3 prime?
Yes.
Yes. The only factors of 3 are 1 times 3. No other way to get it. The only factors of 5 are 1 times 5. No other way to get it. So this one's prime. Is 10 prime, Bryce? No, because I can go 1 times 10 or 2 times 5. Is 6 prime, Bryce? No, because I can go 1 times 6 or 2 times 3. So this one has exactly 2 prime numbers. And the rest, 1, 2, 3, 4, 5, are composite. Is that what I'm looking for?
No.
No, okay. Isn't that what it says? 2 of her cards show prime numbers.
Yeah.
5 show composite.
Yes.
When thinking about prime and composite numbers, listen, at this age level, if you're taking a test with no notes, and you can remember the following. 1 is not prime or composite. 2 is the only even prime number, because the only way to get 2 is 1 times 2. Any other even number is not prime. Any other even number. 28, not prime.
36.
3. 3 is a prime number. Anything that is a multiple of 3 is a prime number. Which means if I took the number 51, 51 is a multiple of 3. I can tell that, Ilaria, because I can add 5 plus 1. That's going to give me 6. And if my rule for 3 is if the digits add together, and we're only doing 2-digit numbers, we're only doing 2-digit numbers in the 6th or 5th grade, 2-digit numbers. So if the 2 digits add up to a multiple of 3, 3, 6, 9, 12, 15, 18. And 5 is prime. Anything that ends in a 5 or a 0, after that's not prime. And you need to know your multiples of 7. But if you can know your multiples of 7, the rule for 3, what even numbers are, you should be fine. Kendall, you had a question.
Why is like 2 is an even number? Why is that?
Okay, why is 2 is prime? Tell me the factors of 2. Nope, those are multiples. 1 times 2.
1 makes
The only factors of 2 are 1 times 2. A prime number has only 2 factors, 1 and itself. That's why the number 1 is not prime, because it only has 1 factor, 1. Okay? Composite, like the number 6, is composite because I can do 1 times 6 or 2 times 3. It has 4 factors. Prime numbers only have 2, 1 and itself.
Wow, 1 is just like in the middle.
The 1's a weird one.
I'm the weird one.
It's the loneliest number, from what I've heard. All right, let's go back to. All right, so we're gonna look at the bottom one with Kendra. So we're all looking at the problem with Kendra. Kendra has 13 medium-sized bags of candy. Each medium-sized bag has 20 candies, 20 candies in each. She has 1 large bag of candy. And how many candies are in each large one? How many? 32. 32 in each.
42.
42? All right, good. 42 in each. And my question asks us, so which of the following expressions represents how to find the number of candies Kendra has in all? Okay, if I want to know what you're thinking, tell me what's... Oh, no. Okay.
That's that song.
If I want to know how many candies that she has total in the medium bag, how would I find out how many pieces of candy in the medium bag?
So you multiply 1 times 42.
No, in the medium.
13 times 20.
13 times 20. And this is going to tell me in the medium bag. In the medium bag. Matthew V. How many pieces of candy in the large bag? And they only have 1 bag. And so this is in the large bag. So whatever my answer choice is, it has to multiply 13 times 20, and it has to add 42. So which one of those problems does that? C. 13 times 20 plus 42. Okay, stop. But I broke it down. I broke it down into each step. How would I figure out how many medium? How would I figure out how many total large? Write down how I would do the medium. Write down how I would do the large. And it's a piece of cake. Boom, shakalaka, peace out, God bless, love you, do something kind today, save the bees, subscribe.